Good morning, everybody, and welcome back. This is weekend number 3, the last weekend of the database class. So the agenda for the weekend, today I'm going to go over some miscellaneous concepts on database connectivity, object-oriented databases, and some Oracle database features. These are what I call my miscellaneous topics. So all the new information will be given to you today. And then after the lunch break, I have the final exam with me. I will go over the final exam, let you know what to study. I have 2 activities for us to do on the database, and the activities will count towards points on the final. So ITU requires an in-class final exam, which means you have to take it anyway. However, I don't necessarily have to use it in all my scoring. So I've got some in-class activities for you to do, just like we did last weekend, or the weekend before I should say, to build a couple of databases. But you'll get points to substitute for final exam grade points. So they can only help you, they can't hurt you. So if you don't do it at all, don't show up after lunch, what ends up happening is you'll end up not having that opportunity. If you do, then you will earn 5 or 10 points, depending upon how much of it you do, towards points on the final exam. So it will replace final exam points. So you'll be able to guarantee that you'll get an A, or you'll get something close to it, hopefully. Because you won't have to worry about the mystery of, oh my god, how did I do on that final? I didn't do so well. And the final is mostly multiple choice, but I did put the entity relationship diagram on there. So I'll tell you, on the final exam, you have to take a business scenario, a description, sort of like what I'm going to give you this afternoon for practice. And you have to take it, write an entity relationship diagram out of it, translate the diagram into a bunch of tables, answer some query questions about the tables, and some queries that would be run on the tables. And then there is about 5 or 6 or so multiple choice questions on top of that. So if you're worried about it, don't worry about it. All you have to do is an in-class assignment, and you'll have most of that exam taken care of for you by using the in-class assignment points that you'll earn as extra credit. So, but I'll talk about that after lunch. So I always like to mention all the good stuff to the people who showed up early. And then everybody else will be like, what? We're also going to be using the same accounts that we used last time for MySQL. I have all those accounts. I have all the information for you. You'll use the same login. You'll just create another database for today. So if you are bored while in the next, I would say hour or so for this lecture, go ahead and look through and make sure you can still access and still continue to debug your internet access or your database access. Yeah? Yeah, I think I actually have one available for you. You are student 50. Student, is it 050? 050. Use that one. And we went all the way up. I think we have 49 available too, but 50 is safe. Actually, hold on one second. I can check right now to see which if we have a 50 or a 49 in here. I have all of your databases here. Unfortunately, because you did miss it, you'll have to go through on your own. And nope, I don't have a 49 and I don't have a 50, so you're 50. And then if we get anybody else, they'll be 49, huh? I could have it. I just don't have I have it assigned. I just don't have a student who's using it. Not everybody. A good five or 6 people didn't complete it from last time. But 50 looks like it's safe to use. So. But your friend here can help you set everything up. There we go. All right, so this is lecture number 7A, and number 7A is on database connectivity. And database connectivity, looking at, well, we were looking at client-server model, and this is what I call one of my miscellaneous topics. And today and tomorrow is all about miscellaneous topics that aren't really heavily tested. In fact, none of it's tested on the final. This is just for your entertainment purposes. Problem is, I can't give you a final 5 minutes after I lecture to you. It just doesn't work well. So I'm going to give you stuff that you might find interesting, that you might use in the future, that is associated with Oracle, its Oracle database concepts. Keeping in mind that this is basically going to be the more practical kind of information that you'll probably, hopefully, take with you and use. In terms of the motivation, most popular form of the database system is the relational model. We know that already. And we know that it is structured with the structured query language. That is among the ways that we write queries. Hopefully we've got that under our belt so far. And the applications need to query a database. So most of what we're doing with client server and distributed databases is putting one out there, sort of like the one you're connecting to, the MySQL server. And then you're writing a script, or you're writing a PHP code or something that is going to connect to the database. Connect to the database, run a query, take the results, put the results back out onto an HTML interface or something to show to the user. Or it's doing the opposite. It's taking information from a form and then submitting the form into the database, and maybe just not really showing the user any of the results, but showing the user a form so that the user can fill it out to process the information. So we're going back and forth with a database server, long story short. And a simple database application sort of looks like this. We don't ever connect directly from the internet to the database. Database is generally on the back-end server. If we're working in a different tiered architecture, we have an application server perhaps that works with the back-end database server, and then we have a front-end server, a web server that works with the application server that works with the web server. Anyway, long story short, if you take a networking class or if you work with networking, you'll sort of get the hierarchies down and all the different scenarios that might exist. But in our particular case, we have multiple databases perhaps that all work with one application, or one application that only works with one database. And these are essentially typical models of an application, and the application is generally web-based these days. It doesn't have to be, however. It could be an application that's installed on an application server, or on a web server actually. And facilitating the communication is kind of the interesting concept. So in the old days, and standard access to a database would look like this, where we have a database driver, number 1, number 2, number 3. The database drivers get loaded. They're managed by driver manager, and then the driver manager, the application server goes through the driver manager to access the databases. And in that particular case, we're looking at an interface level here, the driver manager, which is what we're looking at in this lecture. So this lecture is about the ODBC and the JDBC and the database connectivity, essentially, between the application level and the database server. And it's just nothing more than an abstraction or a way of configuring it to add protection, security, and efficiency to that database server. We really don't want 15 million connections to that server. Not only will the server go down probably, but and won't support the traffic, but it'll be slow going back and forth. So what we really want is a managed connection. And so there are some toolkits out here, and here's one here called ODBC. ODBC architecture, where we have ODBC drivers that are done from an open data interchange. So operating systems load ODBC drivers for the most part. If you want to connect to, let's say, use Crystal reports to connect to Oracle or connect to MySQL or something. Or even Microsoft Access, actually. ODBC works with Microsoft Access. And it's the driver interface that tells the operating system that here's where the database is located, here's the address, here's the port, here's the user access information, the logon, the username, the password, and here are all the objects that are available to the public. And it acts basically as the gatekeeper, traffic guard, database driver, essentially. It's the driver interface. And so through the interface, we talk with the interface, and the interface talks with the data sources. So we might have multiple databases out there, multiple Oracle databases, multiple client-server databases of some sort, or just one. We don't necessarily need to configure it for the masses. So Open Database Connectivity, or ODBC, is the interface. So as I was mentioning before, and so here's more of a textbook kind of interface to it. I can access and process SQL databases. That's that's database management system independent. We don't care what it is, which is actually kind of the benefit to using this. If we're using an ODBC interface to the database, then the interface can be written as the APIs of the interface can be used. We just swap out the database. So a customer doesn't have Oracle, they have MySQL. No problem, just swap it out. When we swap it out, or not even have to swap it out, we just connect to it. When we connect to it, we're using the same driver commands, the same calls, the same information, same format. So ODBC came around in the beginning as a kind of a convenience way of making all the connectivity the same. It's not the same on the underlying database side, but the connectivity to it's the same. So we have a data source, and that's the database. It's associated with the database management system, anything, usually on a networked platform. The driver itself, which is normally supplied by the vendor. So Oracle actually at one point was providing now. We have third-party companies that also provide Oracle drivers that work with different platforms and different ODBC drivers, and then different programming language drivers, like as an example, JDBC. So JDBC is the Java version of the ODBC, theoretically. So here we have the database management system driver, and then we have the driver manager, and then the driver manager supplied by the vendor of the platform. And the application is running. Well, what does that mean? In Windows, the older versions in the control panel, the driver manager sat there and it said ODBC on it. And then you clicked on ODBC and you could add Microsoft Access to it, or add Oracle or MySQL, all these databases to it. And it made a component for the connectivity. So you read and write, send and receive through the ODBC driver, and the driver communicates with the database. Which is actually kind of interesting because that's generally how Java beans work. If you're going to put an enterprise system up there, and you're going to make it on a Java EE network, and you're going to stick beans out there, the beans are going to communicate with the applications, and then they're going to communicate with the database. So they're sort of standing there like a driver, and then the bean manager, the server manager, is going to manage all those little beans and get them to essentially conform to certain standards and have some common behavior among them. It's really an object-oriented kind of concept. But here's an example on the bottom, the control panel, administrative tools, data sources in Windows. I believe that's still there, actually. Although we don't use very many databases on standalone PCs anymore. A lot of it's client-server. Microsoft Access is still around and is still being used. And ODBC can help you connect to it. So you have a Microsoft Access database table, and you configure the driver for it, and then you configure the applications to work through the driver interface, and voila, you have it. So the ODBC interface is system independent, so it requires the drivers, and it provides that you can have and manipulate data through the drivers. So the ODBC really doesn't provide very much protection, or very much security, or very much anything. It's just a communication channel. So you have other software packages you can actually put on there to manage the traffic, because what you don't want is a bunch of bots out there updating your database, changing stuff in the database, doing stuff through the driver interface. So there's many different forms of programming interfaces to this. A lot of people have gone the Java route because Java is used a lot for internet development. If you're going to take the Java route, you're going to take the Java version of the ODBC, which is the JDBC, which is going to talk about in a few minutes. And if you do that, the JDBC interface is primarily focused on efficiency. And there's a bit of security in there, but it's primarily focused on making it faster, making it run faster, making it run smoother. So the manager itself bridges the difference between the ODBC and the database management dependency. So it makes an independent interface between a platform-dependent manager. So here's an example of the ODBC standard API. And then we have the application that works with the driver manager. And the driver manager might have different drivers set up for SQL Server, DB2, Oracle, other components that are out there. So as I was mentioning before, a very popular area of development these days is the JDBC interface. So it's written in Java, and if you want to write a Java program that accesses data sources and databases, then this is a good choice for you. And so we have the JDBC API, which is Java's database management connectivity engine. So it specifies the interface. So we have an interface, because Java uses real interfaces actually. So we have an interface, we extend a class, we implement the interface. The interface has all of the template to be filled in, or I should say methods to be filled in, to facilitate the connection, disconnection, the send a request, receive results, all the different methods for the connectivity. So an interface in Java can have many different implementations, so it provides a convenient way to realize many different drivers. So if you turn it into an object-oriented connection kind of concept, build an interface for it in Java, have all of the classes implement the interface, and then you have a more reproducible, streamlined kind of concept that comes out of this. So it also provides a JDBC API for standard ways of connecting to common relational databases as well. So this slide is very similar to the last one I just showed you, but instead of JDBC or ODBC, now it says JDBC under here actually, and then it says standard API. So it's the same thing. We're just putting a Java application over here that's connecting to the JDBC manager that's connecting to the databases. So it rides in between. Don't really need a picture to know that, but picture says 1,000 words, I guess. It does ride in between, so which is actually kind of funny because usually people don't get it. They go, well, where's the JDBC? Well, how do we use the JDBC driver? Well, if it's riding in between, you're loading it or you're using it in between. So you have the database over there. You don't install anything on the database for this. You have your application over here. You don't actually have to install anything on the application either. You have to call the methods, implement the interface. Once you've implemented the interface, we'll just make an instance of the driver, and you have it. So the driver's running, the application is running, and the database is running, and you have all three of them kind of, if you think about it like a three-tiered hierarchy, then they all work together. So the Java support for embedded SQL. So embedded SQL in Java. So just as I was mentioning before with PLSQL in the last weekend, which wasn't too long ago, it was only 2 weeks ago actually. That's probably why this class seems like, didn't we just meet last weekend? It was the weekend before. So anyway, but long story short, with PLSQL I showed you that you can embed SQL commands in a procedural language. Well, with the JDBC drivers, you can embed SQL commands with the Java programming language, actually, because you're using SQL commands with Java. So we have embedded SQL in Java, or SQLJ. So that's one version of it. It provides a standard way for Java programmers to interact with multiple databases, but at a higher level than the existing JDBC API. So this is along with, by the way, along with JDBC, we have the SQLJ. Not along with, one or the other. You don't have to use them together. Just because you're using JDBC interface, you don't have to use SQLJ. So the embedded SQL basically allows the connecting of the database itself and includes the SQL code right there in the program. So you don't have to go write code, use it in the program. Because what you're trying to do is streamline the process, which is kind of the reason why you're using PLSQL. So you can write SQL source code inside of PL. Well, you can also write it inside of Java using the embedded version of SQL. And it makes it easier because you don't have to leave one application programming environment, go into another, and then go back and forth. So the embedded SQL processor converts the SQL statements to Java, and then it adds the code for a pre-compiled time kind of implementation, and preprocessor generates the code, includes the driver functionality. So if you look at the java.sql package and the extensions exception hierarchy, you'll see all of the embedded SQL capabilities and packages that go along with that. So we have a data source and we have a driver approach. If we're not going to take this approach, we can do them both simultaneously, or we can do one or the other. This is just showing you the embedded SQL, which is coming from java.sql. You can use java.sql with JDBC, or you can not use it at all and just use JDBC if you wanted to, using a data source and a driver. So the data source is the database, so it's whatever you're using that's created by a common database application. And your system is going to have the driver for it. So the MS SQL Server Windows system as an example. There's different numbers of JDBC drivers that are available for that system actually. And then for Oracle we have jdbc.oracle.org, which the link still works actually, where we can download pieces of drivers or complete drivers that are already compiled and ready to go, jar files and stuff that we can just install how do you install it? You just copy it into a directory, make an instance of an object of the driver, and then you're done. You're using it. So there's nothing to write, there's no rewriting, you're just implementing the interface to the driver. So in terms of the components, we have the driver manager, which is the, and think of these more like object-oriented components, loads the database drivers and manages the connection between the application and the drivers. And keep in mind, JDBC components can also be used with RMI components and JSP components, and it all works together. It's all Java. So, but they're all separate packages and separate extensions on the library, on the language itself. So then the driver translates the API calls to the operations for the specific data source. And then we have this connection, and then the connection is the session between the applications and the driver. So we make a connection, and then we talk back and forth with the connection. We have a thing called a statement. Well, that's an SQL statement that's going to perform the query or the update operation. And then we have the metadata, which is the information about the return data from the driver and the database. So it's the data about the data about the query, things of that nature. And the result set, which is the logical set of columns and rows that are returned by executing a statement. So Java supports the database facilities, provides the classes and the interfaces and all of its components. So the classes themselves, we have a driver manager class. We have a connection interface, which is an abstract class actually. A statement interface, which is going to be instantiated from an actual SQL statement that you're going to create. And then a result set interface, which is the interface that's going to come back from the result set. So if we look at java.sql, that's implemented via the Java SQL package. Supports SQL2, well, that's the current version. So it supports current SQL. And there's a definition for objects for remote database connection, executing queries, performing all sorts of different functionality. And then there's 8 interfaces that define objects. So the interfaces are the statement, callable statement, prepared statement, database, metadata, result sets, connection, driver. These are all the different interfaces to work with. So what I'm going to kind of do is show you the pieces put together in terms of a step-by-step. This is how we would actually implement using these concepts. And there's 7 steps to it. So we start with the driver manager. We work with the driver, we work with the connection, we work with the statement, then we work with the results set. Java being the easy programming language that it is, doesn't really require very much explanation in terms of the Java language syntax. However, if you're not familiar with Java, you might find some of the language syntax a little bit more complicated. But not to worry. It's actually understandable in terms of the step-by-step approach to it, so you don't necessarily have to worry about the details of it. But if we look at the concept of it and take from a kind of a primitive kind of implementation of it, the first thing we have to do is find the driver. So once we've found a driver that we liked, we're going to download it. In fact, most of the Oracle drivers for JDBC that are written by Oracle actually perform better than some of the other ones do, because they support more of the interfaces to the actual features of the database, because they're written by the database manufacturer. So in the beginning, once you download it, the way you download it, it's going to be a jar file. You're just going to copy that into your Java path, probably where you have your class path set to. So where you have your other Java program files are. So you copy the file in, and then inside of your source code, you're going to create a program that's going to connect to Oracle. So when it connects, first thing it's going to do is load the driver, which is kind of easy. I mean, it's just going to make an instance of the driver that you downloaded. And the source code for it is like 1 line of code, which is why people prefer to do it this way. It's just a lot more streamlined. So you're registering the driver directly or automatically, and if you directly do it automatically, it's going to be class, and this is the statement that you would use for it. And just say that class.forName, and why they said forName, I don't know. They should have just said name. But class name, well, this is the class object I'm going to use, and it's going to be org.oracle.driver. And there's an actual file that you downloaded that says org.oracle.driver, or there's something inside that package that's defined inside of the jar file that you downloaded and you copied over that has that in there. So when calling it, you're going to call it automatically. It creates an instance of the driver. So you're wondering, well, why would I have to make an instance of a driver? Well, how else is it going to be loaded in an object-oriented program? You have to make an instance of it. And then register the driver with the driver manager. And then you're wondering, well, how do I get the driver manager? It actually gets created for you automatically when you make an instance of and you load the driver. So once you load the driver, which is really the first step in this process, then we're looking at defining the connection URL. And then we're looking at establishing the connection, creating the statement object, executing a query, and then processing the results, and then closing the connection. And after you get done kind of looking at this summary, you're going to ask yourself, why in the world does this thing seem so difficult? This is the easiest approach. This is the easiest, most streamlined way of connecting through Java. So if you find this to be overly complicated, then and it's not actually, then you probably aren't going to write an application that's going to connect to an Oracle database or to a MySQL database without having somebody else do it for you, I guess. I don't know. This is definitely the beginner's approach to it. So identifying the data source. So it gives you the required information that you need, the URL for the data source. We are working with client-server databases. They're not going to be installed on a local computer. You're going to write a Java application that's going to connect to a server. You're going to have to give it the connection location. We're going to do attendance now. So I'm going to pause this for a second here. Okay, so I was talking about these steps taken to use JDBC to connect to a database. And I want to go back up here just one more slide. There are 7 steps you take. The first step is to load the driver. Second step is to create the connection using the connection URL. Third step is to actually establish the connection. And then to create the statement object, to execute the statement object using a query, process the results, and then close the connection. So the easy part is really loading up that driver. And as I was mentioning before, it's a matter of downloading it, copying it into your class path, and making an instance of an object of the driver. Once you've done that, then you're going to connect to the database. So you have to give the database the connection URL, which is going to be the location. So your IP address, your directory structure. Here's an example down here, foo.itu.edu, my database or something, wherever it happens to be. And then if it is open to the public, as an example here, localhost, that would be on a local machine. If it's open to the public, then you can download it, you can connect to it from any computer. If it's available on the local, intranet within the company, then you're connecting through the URL to the database from there. But however you connect to it is going to be dependent upon where it's located. So the connection URL gives you that. Another option is to create an instance of the driver and then register it with a driver manager, which is very much so similar to an RMI kind of interface. So if you have a driver manager out there, then you create the instance, register it, and then let the manager do everything. And then you tell the manager about the connection and about the login, the admin or the user login and the password and all of the information that's associated with that. So here's an example of the source code that you would write to do this. You'd go create a new driver, and that's going to be the driver. And this is all one line of code, by the way. And the driver is going to be the driver that you downloaded, .new instance. Running a new instance method creates that new instance of the driver. And then the driver manager .register driver to register it with the driver manager, as an example. Now, a connection to a database is simply a connection to the database. Actually, it's just exactly how it sounds. It is just basically connecting, so it represents the session of a specific database, a specific table. So within the context of the connection, the SQL statements themselves are executed, and the results are returned to the user. So in terms of our connections, there's multiple different connections that we can establish. And it provides the metadata or the information about the database and the tables and the fields. And once we open the connection object, we're using the connection object, we just read and write, and we request things of the connection. So we're no longer speaking with the driver anymore. And the connection is managed by the driver. So the connection object has its methods, deals with its transactions. So here's an example of the Java source code to actually create a connection. And you're running a constructor here from connection get connection. And the connection has a string. The constructor is going to take a string, a username, a password, send it over to the driver manager who's going to connect to the database using the URL, the username, and the password that's associated with it. So it connects to a given JDBC URL within the given username and password. And it could throw a Java SQL exception if there is a lack of connection or if there's a problem with that. So it returns a connection object once the connection object is created. Just like the constructor returns an instance of an object in any other situation, it returns an instance of an object for the connection that represents the connection, and then the connection itself is able to be used as an object. So here's one creating a connection using connection. The name of the object, this is the connection object. The name of the instance we're creating is the lowercase connection. And this is going to be from the driver manager.get connection with Oracle localhost movie database, test user, password. This is just made up information for a movie database as an example, and a test user and a password. So once we've loaded the driver, we've created an instance of a connection object. Now the next thing we need to do is figure out what we're going to talk to the database with. So we send statements. So the statement is an SQL statement. So we create a statement object, and we use the statement object to represent the statement. We send the statement to the connection. We say execute the statement, and then the statement runs. So the statement has a create statement method to it, and it returns a new statement object, and it's used for general queries. We also have a prepared statement. Prepared statement is used to create a statement that's going to be run multiple times. So we prepare it. We say we're Barnes & Noble, and we have a database of publishers, and we have books in there. And in these publisher databases, we're going to be searching on this author, and then we might be searching on this other author. We have 5 different authors we're going to search on as an example. So when we run the prepared statement, we could say, select author from this database where, I don't know, subject matter is equal to something or other. So we're running a query, and then we do a prepared statement. We cache the statement over at the database, and then we keep sending it, okay, author B. Hecker, okay, author Jones, author Miller, author. We keep changing the name of the author without having to run the query all over again. So prepare statement allows us to make it more efficient, which was one of the design objectives of JDBC, was to make it run faster. Because the slowest part of most applications is that database connection. You don't want to spend a lot of time. Once you've made the connection, you want to keep the connection, which is what JDBC is doing for you with that object for the connection. And then you want to do it in an object-oriented fashion because you're working with an object-oriented language. So you don't want to have to go from an object-oriented language to a scripting language back to an object-oriented language, which is what you get with PHP and other languages if you're trying to use another driver interface with it. But long story short, if you streamline it, make it object-oriented, make it prepare statements ahead of time, save stuff, cache stuff, have an open connection that stays open and then shuts when you need it to shut, then you have a streamlined process, which is what the Java approach is actually doing. We also have a callable statement. So we have 3 different types of statements: prepare statement, callable statement, and the regular statement. And the callable statement returns a callable statement object. Obviously, it's for stored procedures. So we can run stored procedures through a callable statement. So our statements, well, it depends on what the nature of the statement's actually doing in terms of how we're going to execute it. Sometimes we execute a query, which is this one over here, or we execute an update. So executing an update would perform a change on the table, but it's really not going to give us a result set that comes back out of that. But executing a query, we're going to get a result set. So the statement itself is the SQL statement, and we send the SQL statement through the system to the connection to go to the driver to go to the database. And if we have an execute statement, it's used to return an output result. So we take the output result, we do something with it. And then we have objects to manipulate the result that comes back out of that. And if it's an execute update, then it just returns. There's no output that's going to happen with it. There's no return that's going to come out of it. So So in terms of executing queries and updates, the result set executes a query with a string, and you execute an SQL statement that returns a single result set. In the integer execute update string, you're going to execute, and here's an example here, SQL insert, update, delete, statements, all sorts of different things are going to be doing an update. So people used to refer to them, and they still do, as DDL versus DML, but it's not really. You can run DML and you can run DDL commands through all three of these actually, these different statement options. But the big trick and the big difference between the execute update and execute query is, do we have a result set? Anything that returns something that we're going to look at is going to be an execute query. Everything else shows up in the execute update category. It's just going to return the number of rows. So the other thing that was added to JDBC to make it more efficient, more streamlined, easier to use, faster, better, in terms of the interface, is this timeout. In fact, that's one of the biggest problems in trying to design a GUI for a database connection. We sit there and we wait, and what are we waiting for? Well, we're waiting for the connection to get established, and then a query to run, and the results to come back, and then we're going to parse the results, and we're going to give the user something. Time consuming. What if there's a break in the connection? Wouldn't it be nice to know about it? And then the user won't be going to a different page and then coming back, or quitting the application and starting it back up again. So we put a set query timeout in there to say we're allowed to wait for a certain amount of time. After that certain amount of time, then forget it. Come back with an error. Sorry, the database is not available right now. It's sort of like what ATM machines do actually. It'll come through and it'll say immediately come back and say, sorry, no connection. Because right in the beginning it will establish that, oh, we can't connect. Sorry, the service is unavailable right now. Or we ran out of paper. No paper right now. Immediately, which is what you're kind of trying to do with your application. So a lot of applications are actually built with the timeout. So you put the timeout on there, and after the timeout, it's either completed or not completed. So then you can put up your little wheel. Your little wheel is going to go for a certain amount of timeout, or your little status is going to go for a certain amount of time. It's a fake timeout because maybe it's already done, but the status is still going. But if it's not done by the time the status is over with, it's not happening. So it comes back and you immediately can basically create a better user interface, user experience by playing around with some of the features with this. Also, the SQL exceptions can help you a bit as well. When the system comes back and says, sorry, your PIN is wrong. Oh, okay. And that would be an exception that would come back and say, hey, username was okay, but the PIN came back wrong. So we know that the password was wrong or something. So the timeout sets the timeout for the driver to wait for the statement to be completed. And then the operation is not completed in a given amount of time. We get an SQL exception that is thrown. What is it good for? Well, as I just mentioned before, the user interface, the user experience. So as I mentioned before, and we talked about not last weekend, but the weekend before when you guys were here, we talked about the cursor. And the cursor was this basic little piece of memory that was stored on the database end. And we read and wrote to the cursor when we wanted to change the result set that came back. Well, what is the result of the query? Well, it is the cursor. So it's coming from the cursor information. How can a database send the results of the query through the communication lines? Well, it reads the cursor, and it uses the cursor to go back and forth. So the JDBC interface is designed to use the cursor. If it is, then it has the metadata. So we know what the names of the rows were, what the names of the columns were. We know what size they were, what data type they are, and then we also have the data of the rows that were returned that are inside of each one of these columns. So it makes it a lot easier to build methods to go next, previous, pull one off of the result set, do something with it, go to the next result set. So result set provides the access to the table of the data generated by the when you execute a statement, it returns a result set, you get the result set object that comes back. So you don't actually have to parse the information that comes back and put it into an object, you already get an object created for it. So execute query populates the result set object. You take the result set object and you go through it iteratively using the methods. And if you're familiar with Java, you know about the containers with abstract data types for queues and stacks and result sets, things of that nature, where you can go through each one of them And you have built-in methods to iterate, iterators and translators and all a bunch of stuff that you can use to manipulate those result sets. So table row are retrieved in sequences, and and the result set maintains a cursor pointing to the current row of the data, and the next method moves the cursor to the next row. And you can't rewind, you can only go next, 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 because it pulls it out of the cursor. When the results are over with, then it takes the cursor and, it's empty hopefully, and caches it out and removes it. So in terms of working with the result set, we have Boolean and then we have close. We also have open that can be worked with that. So next activates the next record or next row. There's a first call to next. Activates the first row, gets you the first one, opens it up, and then it returns false if no rows are left. So it will determine if there's a row in there. And then close disposes the result set, closes it up, automatically called by most of the statement methods to begin with. So getting values from the rows, we can type a get type. So it's sort of like converting it to a float or to an integer. Well, before we convert it, we can actually get it. So in this particular case, there's an example, get int 5 spaces, and get a string of 3 spaces. So returns a given field as a given type, and the field indexes start at 1, not 0. So, and then also we can get the column name, column index. We can return it to a find column. So the JDBC interface actually works with the metadata, so we can actually refer to the columns that were actually in the database table that ended up in the result set. So here with the get type, it's the same as the this type up here, but we have a string instead of an integer, and we're getting the name of the column. So it uses the name of the field. A little bit less efficient than the actual index of the field 0 through 1, or excuse me, 1 through 5, or however it is. So this would be taking field number 5, column index 5, and turning it into an integer, or number 3, turning it into a string. It's not the length, it's the column index number that's being used here, not to confuse you. Also finding a column, looking up a column by a given name. Give me the first name or give me the last name or something, and then find the column. So the JDBC interface also supports the is-null concept and the null concept in general. So in SQL, null means that the field is empty, not the same as 0 or not the same as a space. There's actually a null in there. So JDBC must explicitly ask if the field is null by calling result set.isNull on a column, and then we know if it's null or not. So we can actually use with a column, we can actually use the database metadata and the column data as is without having to translate it to something else. So we do have a little bit of a mapping between the Java data types and the SQL data types, where in PL/SQL we don't have any mapping, where it's the same identical data types. So one of the, I wouldn't say disadvantages, but one of the things with Java is there is a bit of a translation that goes on. But the SQL types and the data types for Java types are pretty compatible these days. So there's been a lot of extension to add these types. So the character, the variable character, long character, well, that's equal to the string. Numeric decimal is the java.math.big decimal. The bits, the boolean, tiny bits, byte, the small int is the short. So what ends up happening is you'll have, in the date, we have support for the date and the time in SQL. So java.sql.date, java.sql.time, and the timestamp information. So long story short, we have the ability to kind of see the translation and then update the Java language to, which has been done over the years, to complement, to support SQL database types rather than just programming types. In terms of the database databases in generally have timestamps on them, dates, times, all sorts of different information that gets translated. The times in SQL are non-standard, so the Java defines 3 classes to help you. So we have the SQL.date, SQL.time, and SQL.timestamp that are used. So we have hours, minutes, and seconds, and months, and days, and stuff. So anyway, long story short, what ended up happening was they developers have extended the Java class libraries, or standard packages, to include support for SQL. And everything is in the SQL package. So SQL dates and times are one of the things that were significant value that was added to it. We also have the ability to optimize our statements by using that prepared statement, as I mentioned earlier, and also using stored procedures. So in the prepared statements, the SQL calls that you can make again and again and again, well, which means you make the generic SQL statement. It's almost like substituting words in there. So instead of searching by this author, you're searching by another author, and then another author, if you're using that kind of format or that example. So it allows the driver to optimize the compile series and creates a connection.prepared statement. And then we're using stored procedures. So we can use stored procedures with a special optimized statement through the JDBC interface. So it's written specific to the database language, and it stores inside the database, and we access it through connection.prepared call. So in Oracle, we can actually create these stored procedures, save them, and then call them like we would if we were sitting there at the server. Stored procedures are good because they provide a little bit of glue, a little bit of calculation without having to run a query. We store it. It's a function, essentially. We store the function. And then we just run the function over and over again when we need to. And the function might be querying the database, finding something, or it might just be just doing a mathematical calculation, a conversion from Fahrenheit to Celsius on something, as an example. So here's an example of the prepared statement, if we were to use one. We make an instance of the object type is prepared statement, and the object reference is update sales. And then so we're going to put a string in here, and the string is a query. And we have question marks in the place of the substitution values we're going to use in the prepared statement. And then on the connection object, we're going to run the connection.prepared statement and send it the update string. So send it the string. And then it looks like I have a little array for the sales for the week. And then we have a little string array for coffees. And then we can update, and here's an example here on the bottom using the prepared statement where we have an update sales.set int, and then it's going to be column 1. We're going to set it to sales for the week I, which is coming out of the array. So we can take data structures inside of Java, as an example, a string array or an integer array, take the information using prepared statement, send the information as the parameter. So you're really doing this in Java, and then you're sending those statements as parameter into a prepared statement, you're running it. It's a really good integration with SQL and Java, actually. So it's a really good support where you don't feel like you're writing Java and then you're writing SQL, then you're writing Java, then you're writing SQL. You're actually doing it together. And if you use the prepared statement, then you can cache the statement and just keep sending it more parameters, which is what this is doing here. These are both sending through 2 different sets of parameters to the same statement, which is more efficient than preparing an SQL statement, sending the statement over to the database, running the statement, coming back with the results, whether we have results or not. So if I were to write the same program in a PHP or JavaScript or another scripting language, hopefully one that was server-side, I would be constantly sending statements to the database and then coming back and actually working with a result set that's empty. It comes out in 1 row updated. Great. What am I going to do with that? But that's labor intensive in terms of wasted time looking at a result set. Why do we get a result set for? What do we need that for? We don't need it. And then also opening up a connection, sending the statement, closing the connection, opening up the connection, sending another statement, closing the connection, instead of having a managed connection. So this is a lot more efficient when it comes to the running. We'll run faster for those people who don't understand the efficiency. It definitely is a streamlined approach, and it's actually easier than writing a script to do it. So here's the class diagram, putting all the pieces together. We have a result set over here in the corner. The result set actually has a time, a date, some information that's in here, and we can get the information out of here. We could set the information through a prepared statement. Prepared statement is going to use a callable statement. It's actually a subclass of statement. And then we have the connection with the driver manager. And the 3 different types of connections, to create a statement, to prepare a statement, to prepare a call. that we're going to use through the connections. So, anyway, long story short, it gives you a lot more information, a lot more capabilities of working with a database connection. In terms of the metadata, we can actually get at the metadata, which you can't do in other scripting languages. So if you have all the data that's coming back, you have the result set, you can actually ask the result set, tell me what columns are in here. And the result set comes back and says, I have this column, and that column, and here are the data types that are associated with it. So result set metadata is what is the number of columns in the result set, the column names, the SQL type, the normal maximum width in characters, for example. That's another good one. A suggested column title for use in printouts and displays. Number of decimal digits. Does the column case matter? And so on. All this stuff would come out of the result set metadata, which is a little bit easier because, for example, you come back with a result set and it's from an SQL database. Let's say, going back to this Barnes & Noble example, it's from Pearson's Publishing, and you come back. Well, that result set is going to be a little different than the one that comes back from McGraw-Hill or another. These are publisher names, by the way. That result set is going to be different. So if you're using a JDBC approach, you don't have to assume, you don't have to pre-program what these are. You can just take what comes back, parse it, whatever's in there gets populated, because maybe the manufacturer didn't put anything in this field, or maybe they don't have this column altogether, or they have a different column. Then you can take what they do have, and then they change it periodically. When it gets changed, the application will automatically read the new data that comes through it. Gives you a little bit more realistic, virtual, not really hard set kind of analysis that goes on. Better results, long story short. So the database metadata is also available. So what tables are available? So you're going to XYZ, brand new publisher. Here's my database. I'd like you to make my services available on your website. Okay. Without having to do anything, you just use the connection and say, well, what tables you got? Well, look, we have one that says books, the other one says magazines, the other one says videos. Ah, okay. And you can organize each one of the table groupings, hopefully, if it's self-explanatory. Hopefully they'll give you some documentation as well so you can connect to it. Users' names, database itself, is it read-only, all that stuff you can find out about a database. So useful methods for the metadata: get the column count, get the display size, get the column name, column type, is it nullable, stuff like that. Imagine the case where you want to print the results. You're going to want to know what you're printing, I think, actually. You're probably going to want to know. You can also put in and use transaction management. And I have another lecture for you tomorrow, actually, on transaction management and how it's facilitated through databases. So a transaction is a sequence of statements. We know that, I hope. And that it's not an explicitly open and closed. There's one statement, another statement, another statement. Actually, Java has Java Transaction Authority, JTA, that you can use with this to keep track. So you can mark the start and the end of a transaction. If all of the statements worked, then commit it. One of the statements didn't work, then don't commit it. Well, which one is not going to work? How many times have you tried to order something through a shopping cart and the item was out of stock? Do you really want to pay for it and have it shipped and everything when this item doesn't exist? It's not in stock. It's back ordered. So if you're using a proper transaction management system, you can stop at each part and say, okay, we're at the point, credit card information was entered in, everything was ready to go, we're going to do the shipping, we're going to pull it out of inventory. Oh, wait a minute, it's negative. Uh-oh. And then it can come back to the user and say, sorry, your item's no longer in stock. We got the inventory wrong, we can't ship it for you right now. Do you want to continue and have this on back order, or do you want to cancel this order? And let the user decide. Or you can just, as the application, we don't want to do back orders. Nobody orders anything back ordered from the internet. You just go to a different website and order from there. So, long story short, that's what the customer's probably going to want to do. So the transaction manager that's set up can, once it's registered all the statements that belong to a transaction, at a certain point, it can do its own exception handling and figure out, well, I think we should cancel this order. Reverse the charges, reverse everything, take the customer out of the system and just say, sorry, order's been canceled, we're back ordered. Hopefully that would happen before all the credit card stuff was put in. but hopefully it depends on the series of steps that are established. So instead, the connection in a transaction manager, we want to make an auto commit if everything works. If not, roll it back. So a connection has a state called an auto commit mode. We can turn the auto commit mode off and not auto commit it. So if auto commit is true, then every statement is automatically committed, and the default case is true. So we probably want to turn auto commit off for that, so we can roll back. Otherwise, we've already charged your card. What have we charged your card for? Nothing. We don't have the item in stock. We thought the item was in stock because we pulled it from a different database, but when we went to go ship it, we figured out, oh, we can't ship to your state, or we can't ship this product at this time. So the auto commit is a way of turning it on and on with a boolean. So we have a set auto commit true or false. And so if the auto commit is false, then the statements are added to ongoing transactions, and then at the end of the transaction, then you can explicitly roll back or commit something by going connection.commit, connection.rollback. And it will commit and roll back everything that's involved in that particular transaction. So for the connection manager, you don't actually have to use one. You can use single connections. Or you can create a pool of connections, put them in and organize them through a connection manager. So for large threaded database servers, you want to create a connection manager object. So you don't have to manage each one of the individual connections by themselves. So the responsibilities, it's responsible for maintaining a certain number of open connections to the database, only allowing a certain number of open connections, which will help you from denial of service attacks and things of that nature. When the application needs a connection, they ask for one from the connection manager's pool. So if the connection manager is keeping track of 5 connections, we have one open, the application wants to use it, we don't have to open a new one. We just send it to an existing connection. And so we can essentially save time without having to open, close constantly. It's kind of like how RMI actually works. RMI, we have a manager, remote method invocation manager. RMI manager sits out there and manages the objects that are out there. Creates 5 objects, in this particular case maybe. Makes instances of them. Application requests an object, comes in. Oh, we have one, it's right over here. Services up the objects that are already in existence instead of creating new objects. And then we have a pool of reusable remote objects that the manager organizes and says, okay, you're allowed to touch this one, you're allowed to come over here and use this one, and basically sets the privileges, sets the access restrictions, and configures the system essentially. Why do we want to do this? Because opening and closing connections takes a long time. Why not just open them up originally, keep them open, and have everybody reuse them? Same thing with RMI. Why do we have all those objects? Why do we care about managing all those objects remotely? Because we don't want each new connection to create its own objects. That's very inefficient, and it's time consuming. So we want to save time and we want to save resources. What are we saving? We're saving money. We're saving memory resources because we're not having to create 5 different objects when everybody's using the same objects. Why don't they all use one object instance? So the same kind of concept that was implemented in RMI is actually translated over into JDBC in terms of its methodology for its creating of its instances. Let's see. A warning here, the connection manager should always set auto commit to false when a connection is returned, just in case something fails. If you want more information on this tutorial, you can go online and take a look at JDBC. Actually, I would just do a Google search for JDBC, actually. There's tons of tutorials on there, tons of examples. If you've written one JDBC program, or you've written them all, because every single program follows the same pattern. There's those 6 steps. You do the 6 steps, you run the objects. Those are the only objects that are available. The entire API is through about 6 different objects. In terms of optimizing this, the illustrated technique above here that I just went through can be optimized in terms of it running a better design for eliminating potential bottlenecks and looking at how can we eliminate bottlenecks in the application design, because what we don't want to do is have the GUI or the user essentially waiting for the database connection, which is what's going to happen 9 times out of 10. So a really bad website, really bad shopping cart, really bad application in general is sitting there waiting for the database to come back and respond to us. And who knows where the database is? And who knows how slow the database is going to run, how slow the query is going to run. We don't know this. So a lot of people take a lot of time and energy in the optimization part of it. So on average, a web request performs 4 database queries. I don't know where they came up with that. They did an average, I guess. So experience has shown that the database calls are typically performance bottlenecks. That's a no-brainer. And a bad JDBC design can overwhelm the database. Actually, it can if you have too many connections being created. So in terms of the API, most versatile versus the most optimized, in terms of a command, an SQL select star from table, that's going to be the most versatile, but not the most optimized. It's going to be the least optimized on the scale, because you're getting everything. That's a big result set coming back out of that. Not only that, but you're running a query. That's going to be hard too. Prepare statements, callable statements, and then caching the data on the client. Caching the data on the client is going to be the most optimized technique to be used. We can actually copy the cursor to the client and then run everything from the client, and then that's the most optimized approach. So in terms of the API, the SQL statements are the most flexible. They're also the least reliable. Must be recompiled in the database for each one of its use. If the statement changes, you have to recompile, which is actually kind of different from using a scripting language. Scripting languages are easier to update. If the password changes, if, I don't know, the URL changes to the database, if the statement itself changes, you go in there and you change a piece of text. For a Java program, you actually have to recompile the object. So it's a little bit more time consuming. In terms of the prepared statement, that represents a precompiled SQL statement, but the parameters are missing, so it's more flexible. You don't have to go in and recompile it. Instead, you just apply it different parameters. So it can be used efficiently to execute multiple times, and somewhat flexible. You can create new ones as needed. And here's an example of using the prepared statement. And I actually covered this with the 6 steps I went through earlier. But with the prepared statement, as an example, we can call it 3 times with one statement. Actually, we can call it 5 times or 6 times with one statement. Are you talking on the phone? Yes. Sitting in the front row in a class talking on the phone. Wow, I just had to say that. Anyway, I heard somebody talking about that. Like, you gonna be talking on the phone? Hello, can I order my pizza for lunch? Callable statements. Callable statements used to execute SQL statements and stored procedures. Same syntax as the prepared statement, less flexible. Alright, so we have prepared statement, callable statements, all basically put in there for one reason only, is to make it more optimized. So we don't have to keep writing new statements. And we're supplying it with different parameters every time we run it. So we're making the statements more dynamic. Another technique we can do is cache the data. Only problem is that the cache can get out of date. So keep the data within a client to reduce the number of round trips it makes to the database. Less JDBC, the better, actually, in terms of what we're doing. So if we cache the results on the local client, great. But what if we're looking at the cached results from a previous query, and we're not looking at the current results? That's the problem with the result sets that are cached. So the cache only works for a certain amount of time. Therefore, the cache is going to be outdated. Also, you're running let's say for example, a Southwest Airlines reservation system, and you cache the results, and then 5 minutes later you go to buy a seat that's in your cached results. Probably not available anymore. So the whole entire transaction is not really going to work, because you're working with real-time data and you made it static, you cached it locally. So caching has to be done with a little bit of caution. In terms of the connection pool, putting it together, connection pool, don't use the driver manager get connection often. Minimize that by creating a pool. So the connection actually takes 2 seconds to create. Funny thing is if the connection takes 2 seconds, the prepared statement takes 2 seconds, or the callable statement is getting the result set It takes 2 seconds, 3 seconds. You add up all those little steps together and you're looking at more than a minute, your application is not going to work right. It has to be under a minute. Otherwise, the bottleneck is going to be the database, and the database is going to prevent your user interface from working correctly. So you can create a pool of connections and then reuse them, necessary for a production system. Any production system is going to have a pool of connections. So basic design technique, you use multi-threaded with connections and pooling to address network latency. And the threads and thread issues. So threads can issue queries over separate database connections, and using multiple threads might be a good case. And that improves the performance. Also looking at simple batch transactions as well. So collecting statements of operations and submitting them all together in one transaction. So in fact, this is a good design for any way of connecting to the database. Save everything up. They filled out the form for the shopping cart. They filled the form out for the user information. They put all their credit card information, and they got everything ready to go. Then send it to the database in one shot. If you send it in pieces, what ends up happening is the application interface runs too slowly. You got to connect, disconnect. The whole thing is going to take longer. So it's better just to batch it up. In a single batch, the database obtains the necessary locks on the rows and the tables and uses everything all in one step, and then it can do an auto commit or a rollback if there was a problem. So depending upon the transaction type itself, the separate statements, and the commits can result in more database calls and hold database locks longer if they're separate. It's like the Southwest example. If you go and you're going to reserve a seat, are you going to lock the database while you're paying for it? No. Get everything ready to go. Go in, grab the seat, lock it, perform all the rest of the transactions, and then release it. Release the row. If it's been taken, then you don't have to worry about it. If it's open, then it's back open to the open pool. So don't have the transaction span over the user interface, long story short. If you have the transaction span, you're waiting for the user. You've locked the table, user's gone to the restroom, has come back 5 minutes later. Oh, I think I'll buy that seat now. No, applications that do that, you know they're doing that because there's a little timer up there that says you have to buy this ticket within 5 minutes or within 4 minutes. Usually it's like 3 minutes. So anytime you've gone into a website and you saw a little timer up there, it's because they're locking it and they separated out the database transaction. It's not all happening in one transaction. So to prevent the user from destroying the experience for everybody else, you say, oh, you have to buy it. You have to pay for it. The transaction has to be complete within 1 minute or 2 minutes. It says, okay, so that means don't go to the restroom and come back, or go to lunch and come back to finish your transaction. Because believe it or not, people used to design transactions like that. Banks used to do that all the time. You left it open, you went to lunch, you came back. Meanwhile, nobody could do anything with your account. It was completely frozen for the time that you were at lunch. So if you went to go use your ATM machine, your ATM card, you actually got denied because your account was locked. It was open because you left it open on your computer. And then they got smart and they went, oh, let's just not do anything. So they cached it all locally. And then some applications actually tell you, your cache might be out of date. Would you like to refresh your information? You're thinking, well, how did something change? It didn't. It's on your computer. It's not on the database anymore. You're reading from an old cache. After about 5-10 minutes, it's going to ask you if you want to refresh it. Why? Because it's old. Well, I didn't do anything yet. I was at the bathroom. So maybe you don't want to refresh it. So applications can send a begin transaction and then an SQL, lock the rows, update something, and then release it. And then the application waits for the user to press something before committing to the transaction. Well, that's a bad design unless you put a timeout in there. And we can also create smart queries to optimize this. So we can make queries as specific as possible. Instead of going select star, we could just select first name, last name. Makes the result set smaller. Put more logic into the SQL statement. And the design will use the SQL more efficiently. And proper use of the SQL can avoid performance problems. So here's one for getting employees in the engineering department. So using database join instead of this one here. So if we join it on the application side, this is actually, people still do this. This is the funny part. I look at databases and I go, oh, why did you run 3 queries and then you took everything and you concatenated it together using the programming language, and then you took the concatenated stuff and you weeded out the duplicates, and then you did all this stuff? We could just join the query, you know, and or you know, you see that select star from everything. Why did you select star? You just want the cost. You just wanted this. You just wanted that. So here's like 2 queries and then joining them on the application side. Slower than just getting them joined from the database. Let the database do the work, and then take the joined query back instead of having to manage. This actually is error prone as well. So you can probably make a couple more mistakes with blanks or with improperly formatted data that comes back when you're doing a concatenation or a join from an application perspective. So minimizing the result set before crossing the network. Yeah, why send back 50 records when you only need 1 or you only need 2 or something? Many performance problems come from moving rows of data around needlessly. Or how about running a query when you don't need to run the query, which is the part that I've never quite understood. Why create a user account when you haven't actually purchased anything yet, when you're not going to purchase something? Why update the user account? So older utilities used to do that. Now they aren't doing as much anymore. Instead, you don't have to have an account. You can go shopping. You can do anything you want when you want to buy it. Actually, not even when you buy it, when you want to commit to buying it, when you're giving the moment that you start giving out your money information, your PayPal account or your Visa information or something like, then they're going to want to create a user account for you. And then it's optional. You don't even have to create a user account anymore. In the old days, it was the exact opposite. It was, here, create a user account. Now you have a shopping cart. Okay, fill it up. It's like, why bother? It's too much traffic going back and forth. It's not very optimal. Use database for filtering. Use the database for business logic. The database does filtering very well. And business logic is very poor. So at least very inconsistent between database vendors, the business logic. So if you're going to use the database for business logic, this means essentially enforcing referential integrity, enforcing rules, making sure that you can't put a record into the customer file that doesn't have a proper address or telephone number or something. So keep the operational data set small as possible. Your query needs to be small, your result set needs to be small. Also, the size of your tables should be small. So if you archive, move non-current data to other tables and join for rare historical queries. Most of your universities do this, which is why when you go back and you order a transcript after you've graduated, there's a lot of students, there's a lot of records, there's a lot of data. Well, they're going to archive it year by year. So you leave a university, you order a transcript. First thing, which year did you graduate? What years were you here? When did you start? It's going to ask you for the years because it has to go back through the archives, because it's not all in the current list. It's all saved, hopefully, but it's not local. They got to go back into another table to go look for it. Otherwise, index and cluster so frequently used data is located and physically localized or closer. You're probably going to end up putting an index on there as well. So indexed automatically by primary key in most databases. So some advanced driver tuning. We have specific options for JDBC drivers. No common standard, actually no common vendor either. Oracle makes some nice standard drivers. The good thing about the Oracle drivers, if you're working with Oracle, is that they have the privileged knowledge of the inner workings of the database. So the drivers are definitely a little bit more optimized. Your other drivers that are out there, anyone who wants to can write a driver for this. They're not necessarily going to be the most efficient or the most safe, or they might have caused more exceptions than some of the other ones will. You might not have as strong of a connection, faster connection, depending upon the techniques that's being used for the network management or some of the other controls on that driver. So it's better off going with the vendor drivers for the vendor databases if you can find one. Tons of MySQL options out there, because we have tons of MySQL database developers out there. Only 1 or 2 Oracle ones. Use the one from Oracle, it's better. Improve performance by reducing the round trips to the database and Oracle driver performance extensions. Yes, you can actually get extensions on the driver to make it more optimized depending upon what you're doing with it. So if you're heavily using connection pools, then get the extensions to support larger connection pools. So you have more connections available to you than the standard set the driver's going to create. So in terms of some advanced database tuning, performance extensions exist for row prefetching and batch updates. Basically, how are you going to cache the information from a row, keep it fetched, and then query the fetched data, the cache data. So number one, the row fetching. So use a client-side buffer. This is what I was mentioning before. If you're going to use a client-side buffer, you're going to have a timer on it, because if you fetch it, you give it to the client, it's going to be outdated the second the client receives it. So how long are you going to keep it on the client side? That's the fetch side. Replace round trips by local manipulation of rows returned by the query, which is actually kind of an opposite thinking. If you want to minimize the amount of traffic, you optimize the query to minimize the result set, so you're not using a select star, but then you have to run multiple queries. If you want to do the opposite thinking, you have all the traffic go at one time, select star, and then cache it onto the user system and then use what you're going to use out of it. So it depends on how many round trips you're going to have, and you're going to reduce the number of round trips by making the queries bigger, the result set bigger. So use Oracle statements set row fetch. Prefetch would actually prefetch the rows. It will take everything, cache it locally, and then you run the query locally instead of running it over the network. Also with batch updates, so we can reserve the prefetch, reverse it essentially, update it all in one shot instead of doing it individually. Does the data going into the database what does for the data going to the database what prefetch does for the data coming from it. So it caches it all up instead of doing it in reverse order, allowing the user to query the cache. It queries up all of the transactions that are going to occur and then sends it over at one shot. So execute it in a batch instead, and then batch updates. Reduces the number of round trips to the database, long story short. So when the number of queue requests reaches the batch size, send the batch to the database. So if you're searching on this, searching on that, searching on this, and you're sending it all, if you can build the application that way. Most applications can't be batched, by the way, because the user's not going to be like, unless it's like an application where, for example, you're adding stuff to a shopping cart or adding stuff to a list, and then you want to update the list with your account. It's kind of like Netflix, actually. You add a bunch of stuff to a queue, and then at one point the queue is going to be updated in your account. But it's not going to be updated until a certain number has been reached. And then it's going to go ahead and communicate with the server and say, okay, update. They put 5 of them in here, okay, update after each 5 or something. It basically makes it so thousands and thousands and thousands of people can connect to the same database. And it doesn't ruin the speed. If it ruined the speed, nobody would use the service. So you can't. Which is actually kind of the concept of the shopping cart, if you think about it, how that came around. Instead of going and looking up each one of the individual items and going all the work with the database to go back and forth, we load it up in the shopping cart, which is really the queue of the list. And then we press a button that says, okay, we're done. When we press that button, it's going to take the batch and then start processing. The first thing it's going to do is check to see, are these things even in stock before we continue? Because what it doesn't want to do is go through all the work to the end to make sure that the transaction isn't even committable. We're not even going to bother with it. And if it is committable, then we'll process things. So it's trying to get rid of stuff all in one shot using a batch approach. Whether you use the batch approach through the GUI, or you use it through the database management. So in summary, the optimization stages themselves leverage the strengths of the database. You want to get the most functionality you can out of the database using the best features that you can. And there's a full range of available options with the Java SQL API. And it's designed for performance, so connection pools, multi-threading, all implemented for driver performance extensions to create faster speeds, more efficiency, less data being transferred back and forth. So the goal is essentially make it efficient, as I was mentioning in the beginning. So why would you want to use a Java API for this instead of writing this in PHP? PHP, believe me, is actually the slowest technique, but probably the most popular because people don't know how to figure out. They can't figure out how to do it in Java. They can't figure out how to do it even with servlets, which is a much faster approach. They spend all this time trying to figure out how to do it in a scripting language. Scripting language is probably the most inefficient way of connecting to a database, but it's the most popular. And you know how many PHP scripts are out there that connect to databases? Hopefully for the purposes of the application that they're writing, they're not connecting very often. If you're connecting a lot, your entire page runs like a snail. Especially, like, in fact, a lot of people do their preferences and things on the pages through a database using PHP. They'll go query the database, pull a picture out, transfer the picture out, all the data. And you're sitting there waiting for the page to refresh. It's just slow. If you do it through a Java interface, much faster. Much faster. So a lot of the techniques in terms of connecting to the database, and the theme of this lecture was basically to kind of introduce you to the concept of connecting the application approach through a tiered environment. So you're probably not going to be running your applications from the database server. Instead, you're going to be running it from an application server. It's probably going to be running over the internet interface through a web server. You're going to be connecting it hopefully through a technology like JDBC or something that's going to allow you to make efficient use of the database connection. If not, you're doing things the slow way. It might work, which is great, but it may not necessarily be the most optimal. Alright, so I'm going to end this recording.